So measurement. So in this lesson, students should be able to identify and measure. We're going to be looking at potential difference, current, and resistance. So what we're going to look at now is electricity. And related to electricity are these three properties that are called, so we have what's called current, we have and that's abbreviated as amps, and it's measured in the ampere. We have voltage or volts, sometimes it's called potential difference, and then we have this other property that's called resistance. So we really want to try and understand what is electricity and then what are these properties. So electricity really revolves around this subatomic particle inside atoms that are called, it's called the electron. Okay, so if we remember, you can think about the electron as this negatively charged particle. And essentially what electricity is this negatively charged particle, it can flow through materials. So it can easily flow through some materials, and then other materials finds it hard, finds it kind of hard to move through them, and then there's other materials that it can't move through at all. So that's essentially like electricity. That's like basically what electricity is. And then you have these three properties then that relate to this movement of electrons through material that allow them to move through them. So as an example, if we take copper, for example, so copper wire. So if you take in your house, if you look at any extension lead, essentially what you're going to have is you're going to have like a plastic covering, but underneath that plastic covering you have copper wire. And this is what like an atom of copper looks like. So this is what's known as the electronic configuration of copper. And copper basically is a really good conductor of electricity. So that just means that it allows electricity to move through it very easily. And when we say electricity, it allows the electron to move through it really easily. So if we take, for example, imagine this here is a piece of copper wire. So this here is a piece of copper wire. Essentially what electricity is it's the movement of these negatively charged particles called electrons. So these electrons can move through the copper wire. Now, what is it that makes the electron move? Okay, well what it is if you put a charge across this. So for example, if you put a positive charge here, what's going to happen is this negatively charged particle is going to be attracted to the positive charge and it's going to move in the direction of the positive charge. So it'll literally, these tiny microscopic subatomic particles called the electron, they will move through material, good conducting material like copper. So copper is what's called a good conductor of electricity. That means it allows the electrons to easily move through it. So the first kind of property we want to look at is current, and that's measured in amps. So essentially what current is if you were to, let's say, if you could shrink yourself down and you could stand here and you could, let's say you draw a line here, and if you were to count the number of electrons that pass through this point, let's say every second, so the number of electrons that pass this point every second, what you're doing is you're measuring the current or the amperes. So you can think about it like a river, and you can think about these electrons as moving through or flowing through the copper wire. And so basically current is a measure of how many electrons pass through the wire every second. And that's what's known as the ampere or the amp. So that's essentially when you're measuring current, that's what you're measuring. You're measuring the flow of these tiny negatively charged subatomic particles. Potential difference then, or voltage. So this is what pushes the electrons through the wire. And essentially this potential difference or voltage, it comes from the battery. So if you think about the battery, so you kind of have, let's say, a battery that looks kind of something like that, and you have, let's say, this positive terminal, and then you have this negative terminal. And essentially, and then in the middle of this, you have like this insulator. So you can think about it like in one side of the battery, there's a massive buildup of electrons, and they can't go anywhere once the battery's not connected. And basically, what they want to do is they want to go from this negative side over to this positive side, but they can't go there because this insulator that's between the two sides, between the two terminals, stops them from flowing straight across here into this positive side. So what happens then is if you connect this up, so for example, if I connect a wire up here, what will happen is the electrons will flow through the wire and they'll flow down into this positive terminal. So you'll get this movement of electrons. Now, depending on how big this positive charge is here, will determine under how much pressure the electrons are moved through the conducting material. The bigger the voltage, okay, so the bigger the voltage or the bigger the positive charge, the more energy that these electrons will move through the copper wire. So they're going to be forced through at a much faster, or have much more energy. So it's kind of like thinking if you had, let's say you had a mountain, and on the top of the mountain you put a boulder. So you can think about voltage as like the size of the mountain. So if we were to make this really big, okay, the voltage is much bigger here. So the voltage on this one is much bigger. Okay, so when this falls down, it's going to fall down with much more force than if it falls down through here. So that's why, like, when you have like really high voltage electricity, that's why it's so dangerous, because what will happen is if your body comes into contact with that conducting material, the electrons will be passed through your body with a huge amount of energy, and that can destroy all of your internal organs. So voltage, or volts, is a measure of how much force the electrons are being passed through the conducting material. And the last one then is what's called resistance, and that's measured in ohms. So basically, that is like how easy it is for the electron to move through the material. So for example, if you take copper, copper is a really good conducting material, so it easily lets electrons move through the material. Now, on the other hand, if you take something like plastic, for example, that's what's called an insulator. And plastic, electrons can't, let's say if this is a piece of plastic and you have an electron here, the electron can't move through the piece of plastic. Okay, so it can't conduct through it. Whereas if you have like a piece of copper here like this, the electron will easily move through and out the other side. So things like plastic, for example, they are what are called insulators, and they offer really high resistance. So the ohms are they're high in resistance, and that just means that they resist the movement of electrons through the material. So they basically resist the material, and that's really good. So what they do is when they're constructing wire, for example, they'll make, so let's say this is the outside of your like cable, your extension lead. So this is the wire. So let's say inside here you have the movement of electrons, so they move through no problem because this is made of copper. But this material here is made out of plastic. Okay, so what that does is it stops the electrons from moving through it. So the electrons will bounce off the plastic and they'll continue moving through this copper wire. And what that does is it insulates the wire and it stops the electrons moving outside of the wire. So both like really like material with really low resistance like copper and material like plastic that has had really high resistance, they all play their part in relation to humans being able to use electricity. And essentially then is what we do is we can use this flow of electricity or electrons to do some useful work, like to power our laptops, to light a bulb, all of those types of things. So if we take, for example, if we take a filament bulb, so if you have a filament bulb, something like that, that's inside a light bulb. So normally that is made of a material called tungsten, and tungsten it resists so it has like a fairly high resistance. So what it does, it allows electrons to move through it, but it creates an awful lot of resistance. And what that does then is if you rub your hands together, you're going to get like friction or resistance on your hands, and that heats up. Now what happens is that the electrons force their way through the tungsten material, and what that does is it causes friction, and it causes the tungsten material to get white hot. And when it gets white hot, what it starts to do then is it starts to glow. It gets so hot that it starts to give off light. And what you have is you have electrical energy, you have kinetic energy. So kinetic energy is the energy an object has when it's in movement being turned into light and heat energy. And that's essentially like we've been able to use this understanding of how electricity works and how electrons work, and we're able to manipulate material so that we can get it to make like tungsten glow white hot, and that basically is like the basis of what illuminates our room when we turn a light on. So these are the three properties that we're going to look at now. And we're going to look at some calculations as well in relation to these three properties. So electricity is basically the movement of electrons, these tiny negatively charged subatomic particles. Current is measured in amps, and it's basically it's the number of electrons that are moving through a material. Potential difference is like the force that's causing those electrons to move through the material, and then resistance is how easy or how hard it is for the electrons to move through a particular material. Materials with high resistance, like plastic, they resist the movement of the electrons. Materials like copper with low resistance, they allow electrons to move through it really easily. So let's come back to this then and let's look at it. So basically current. So current is the flow of charge, so the negatively charged electrons, through a circuit, and current is measured in amps or the ampere. An ammeter is used to measure current. So this is what an ammeter looks like. The current has the symbol. It has this symbol I. Okay, it's like an I, and that represents current. And the greater the current, the brighter the bulb will be. As potential difference increases, the current also increases as well. So if we have a look at this, so this is a simple circuit. So here you have a battery, you have the negative terminal, and you have the positive terminal. And what will happen is the electrons will move from the negative terminal, they'll move through the bulb. The electrons will cause the filament in the bulb to get white hot, it'll get bright, and then what will happen is it'll move through and around to the positive terminal. And what we can do is we can put an ammeter here and we can measure the current. Okay, and the current is going to be measured in amps. So the bigger the current, the more electrons that are moving through. So, and how does that translate in relation to the bulb? Well, the more current that's passing through this bulb, or the more electrons that are passing through the bulb, the more friction in the bulb, and therefore the hotter the bulb will get, and therefore the more light that will be given off by the bulb. Also as well, if we increase the voltage, okay, or if we make like this positive charge really strong, what will happen is the electrons, the current will be forced through the bulb at much higher force, and as a result of that, that will also cause the bulb to get much hotter and get much brighter as well. So that's current, and you have the ammeter, which is used to measure current. The next one then is potential difference. So again, potential difference or voltage. Again, this is like how strong the battery is and how much force it can force the electrons around the piece of copper. So a battery pushes electric charge around the circuit, so that's what a battery does. The potential difference is the pushing power of the battery measured in voltage. Okay, so the bigger the voltage of the battery, the more force the electrons are pushed around through the conducting material, which is normally copper. So the bigger the voltage, the stronger this bulb will glow, the brighter it'll glow. The potential difference or voltage of a supply is a measure of the energy given to the charge in a circuit. Okay, so it's like the force that the electrons are moved through the circuit. It is the pushing power of the battery. A voltmeter is used to measure the potential difference of a battery, and this is what a voltmeter looks like. A multimeter can be set as a voltmeter to measure potential difference. So a multimeter basically is an instrument that can be used to measure voltage, current, and resistance. So that's why it's called a multimeter, because it has multi-purposes. The red terminal is connected to the positive terminal of the power supply, and the black is connected to the negative. So you can connect it up like this to the battery, and you can measure the voltage of the battery using a multimeter set to measure voltage. So that's voltage. So voltage it's like the pushing power of the battery. The bigger the voltage, the more force the electrons are pushed through the conducting material. And the last property then is resistance. So as I say, certain materials, they don't let the electrons move through it as easy as other materials. So they're, whether or not they're high in resistance. So resistance will reduce current in a circuit. So basically resistance, like, it reduces the amount of flow of electricity in a current in a circuit. So resistance is measured in ohms. So this is the symbol. So the omega symbol, it's a Greek symbol, and it's measured with an ohm meter. So this is what an ohm meter looks like, and you can also use a multimeter and set it to measure ohms. As the resistance increases, the current decreases. So a way you can think about that is you can think about like a hose pipe. And let's say if the hose isn't kinked at all, or you don't bend the hose and you turn the faucet on, or you turn the water on. So the more you turn the tap, that's like increasing the voltage. You're forcing the water through. The amount of water that's flowing through the pipe is like the current, and then the resistance is like if you start to kink the pipe or bend the pipe a little bit, what will happen is it will reduce the flow of the water through the pipe. So that's kind of like what resistance does. As resistance goes up, it reduces the flow of electrons through the conducting material. So that is resistance. It's measured in ohms, and we use an ohm meter or a digital multimeter to measure ohms or resistance. So what we're going to look at now is some of the calculations that you need to know how to calculate when it comes to these three properties. So this is the triangle that you use. So you have V is voltage, I is current, and R is resistance. So resistance, current, or voltage can be measured using this triangle, and we're going to look at some examples of this now. So let's have a look at these three types of calculations here that you could be asked. So you could be asked to calculate voltage, current, or resistance. So the first thing we want to do is we want to look at how do we go about using this triangle. Okay, so the first thing you want to do is you want to read your question. So the first question is calculate the resistance. So we're calculating the resistance of a bulb that has a current of 3 amps when connected to a 10-volt battery. So what we're doing is we're measuring resistance. So what you do is you cover up resistance. Okay, so what we can see then is that resistance is equal to voltage over current. So basically you cover up, so for example, resistance, and then this line here represents division. So it means you're dividing the top by the bottom. So therefore resistance is equal to voltage divided by current. So then what we do is we take, for example, voltage, and we take current from the question. So if we have a look at, so it tells us here that the voltage is 10 volts, and it tells us that the resistance is 3 amps. So what we do is we just take these values and we substitute them into our formula. So therefore resistance is going to be equal to voltage, which is 10, divided by current, which is 3. So if we divide 10 by 3, that's going to give us, it's 3.3, okay? And we can just round that to 3. So that is the resistance, and that's going to be measured in ohms. So it's going to be 3 ohms. Okay, so it looks something like that. So if we look at the next one then, so let's have a read over this question. So it says calculate the current. So we're being asked to calculate the current, and current is, remember, it's represented by an I. So we're looking at this one here. So basically current is equal to voltage divided by resistance. So it's going to be, so we just write out our formula. Current is equal to voltage divided by resistance. And then what we can do then is we can take these values from the question. So the voltage we can see here is 10 volts. So calculate the current running through a wire which has a resistance of 2 ohms and voltage of 10 volts. So voltage is 10 and so voltage is 10 and then the resistance is 2. So we can just take these values and we can substitute it into our formula. So the current, is going to be equal to the voltage, which is 10, divided by the resistance, which is 2. And that's just going to be equal to 5. So it's 5 amps. Okay, so that's the current. And then the last one then, so it says calculate the voltage. So you're being asked to calculate the voltage. So we just cross out or cover up what it is that we're trying to calculate, and we can see that voltage is equal to I line R, and that means I multiplied by R. So therefore voltage is equal to the resistance, the current multiplied by the resistance. So then we just take our values then and we read the question and we take the values from the question. So calculate the voltage of a wire which has 10 amps of current. So the current is 10 amps. So that's I. Okay, multiplied by, so it's going to be equal to, so it's equal to 10 multiplied by the ohms or the resistance. So the resistance is 5 ohms. So it's 10 multiplied by 5. And that's going to be equal to 50. And so we're calculating voltage, so it's going to be 50 volts. So that's basically how you can use this triangle, for example, and carry out calculations to work out voltage, current, and resistance. So that is electricity, and that is the properties of current, voltage or potential difference, and resistance. Okay, thank you for listening.